I'm saying, are you going to solve it with us?
Yeah, we'll solve it together, inshallah. Don't worry. Okay, so geometric distribution. So first of all, let's go over the theory. You know how uh, there's theory for binomial distribution. We get to know how mean is calculated and how what the probability of success is, what the probability of failure is. So just like that, let's go over the theory of geometric distribution. So first of all, in geometric distribution, the number of trials are not fixed. Okay, and not only that, they're not fixed, they continue till the desired outcome is obtained. And they continue till the desired outcome is obtained. What does that mean? That means, let's say that the desired outcome is that a die lands on a 6. So you'll carry on, you'll keep on rolling it till a 6 is obtained. Okay? Point number 2, same as binomial, is that the probability of success and failure is fixed. Okay? So success is referred to as P. Okay? Success is referred to as P. Failure is referred to as 1 minus P. I mean, that's how it's calculated. Okay? Because the sum of all probability is 1. So failure, which you can call Q, although you'll see it mostly written as 1 minus P only. Okay? But is basically fixed, and it's fixed at 1 minus P. Okay? Then you have mean. Okay? Mean, or E of x, which is equal to what? Which is equal to 1 upon P. Now, what does that mean? That means that the average of how many trials, or you can say average number of trials. Yeah, that's a better way to put it. Average number of trials required to obtain the desired outcome. Where P is what? P is the probability of success. Okay? Like, for example, what's the probability of getting a 6 on an unbiased die? It's 1 upon 6. So if I calculate the mean of that, that would be 1 upon 1 upon 6, which is equal to 6. That means that on average, you need 6 trials to get that 6 that you want. Okay? So that's what mean basically means. Point number 4 is that for first success to occur, on the xth trial, x minus 1 must fail. What does that mean? So for example, if let's say that you have to calculate the probability of tail obtained on the 7th trial. Tail obtained on the 7th trial. What does that mean? That means that heads is obtained on first 6. Okay, now let me explain this statement. Although this will make more sense when we're doing example questions, but for now, let me give you like a gist of it. So if success is considered as obtaining a tail, and a tail is obtained on the 7th trial, what does that mean? That means that it's the 7th attempt where we have succeeded in getting the desired outcome. That means that the first 6 must have resulted in what? Must have resulted in failure. And what's failure in this case? Failure in this case is the opposite of tails, which is heads. Okay? So for example, if the question says find the probability that a 4 or a 5 is obtained on the 6th trial, that means that on the first 5, it was the score was other than 4. Okay? Or if let's say the question says find the probability that 10 is obtained on the first 8th on the 8th trial, that means that the first 7 trials must have resulted in a failure. Okay? Now let's look at the formula. So the formula that we're going to use is this, that the probability of x equals to x. Now I'll explain what everything means over here. Is equals to 1 minus p into x minus 1 into p to the power of 1. Okay, where x is the number of trials required to achieve first success. Now let's look at an example question so that we're better able to understand. So it says here, if the probability of success in a single trial is 0.3, then the probability that it will take 6 trials to obtain the first success is given by. So that's what we have to find out. So first of all, what is the probability of success? The probability of success is 0.3. That means what will be the probability of failure? The probability of failure Q will be 0.7. Okay, so this is the probability of failure, or you can call it 1 minus p or q, doesn't matter. Okay, now the question here says that the probability that it will take 6 trials to obtain the first success. Okay, so that means if the first success is obtained at the 6th trial, so what should we get in the first 5? That means in the first 5, the first 5 should what? The first 5 should fail so that we're able to succeed in the 6th one. Like, think about it this way. Let's say that you pass a test. You need to calculate the probability that you pass a test in the 6th attempt. So if you're able to pass a test in the 6th attempt, what does that mean? That means you must have failed the first 5 times. Or if, let's say, you're playing against a team and the probability that you win against that team is fixed, and you want to find out the probability that it's in the let's say the 7th game that you're able to win against that team. So what does that tell us about the first 6 games? That means the first 6 games must have resulted in a loss. So just like that, if we have to calculate the probability that it will take 6 trials to obtain the first success. Here's how we're going to do it. 0.7 to the power of 5 telling us that there's failure the first 5 times, and then the probability of success in the 6th attempt. So this one that you're looking at over here is actually telling us the 6th attempt. Now let's work this out. Let's see what we get. 0.7 to the power of 5 multiplied by 0.3. So we get 0.05041, which you can later round it off correct to 3 significant figures. But this is basically what geometric distribution is. Geometric distribution, this is something that will carry on till the first success is obtained. Okay. Now this was just a very basic example question. Obviously this is not the kind of questions that we will come across in past papers, but let's do some complex questions and then we'll see what's what. But so far, if you guys have any questions or if there's anything that you haven't understood, please. Okay, so here's a question. This is from May-June 2020, paper 5, variant 1, question number 1. So this was in 2020, this was the first time that this topic was tested, okay? So let's see what it says. It says the score when 2 fair 6-sided dice are thrown is the sum of the 2 numbers on the upper faces. Show that the probability that the score is 4 is 1 upon 12. Okay, so this is just a general question. This doesn't require a lot of, this doesn't require complex understanding of probability. Just O-level or IGCSE probability concept is enough for us to be able to solve this. So you're throwing 2 fair 6-sided dice and you're summing them up. Now, one obvious way would be to make that to do the sample spacing and record all the sums, but here, since we only have to find out the probability that the sum of the score is 4, so all we can do is we can just think of the multiple ways in which sum is 4. So क्या क्या तरीका हो सकता है जिससे sum 4 आ जाए? 1 3, okay, और क्या हो सकता है? 3 1 or 2 2, okay. So altogether, how many ways can we get a 4? We can get it 3 ways, okay. Now what about the total outcomes? Considering कि हमने 2 fair 6-sided dice throw किए हैं, तो total possible outcomes कितनी होंगी? 6 एक में और 6 दूसरे में. So that means 36. So I'll write it down over here. 6 into 6, which is equal to 36. So 3 upon 36, and then if you simplify it, is 1/12. ठीक है, एक मार्क के लिए सूट नहीं करता कि हम जो है वो फॉर्मली उसकी वो करें, सैम्पल स्पेसिंग करें और फिर सारे स्कोर्स लिखें. या अगर आपने ये करना ही है तो फिर मैं ये ज़रूर कहूँगा कि मे बी यू कैन जस्ट राइट डाउन where 4 is obtained. So like for example you can write down 4 over here. 4 जब आएगा, जब एक पे 1 दूसरे पे 3 होगा, 2 पे 4 आएगा और 3 1 पे 4 आएगा. ठीक है, and this is enough. So you can see 3 favorable outcomes हैं. ठीक है, और total outcomes क्या होंगी? 6 into 6 which is equal to 1/12. So there you go, that's the answer to the first part. Okay, now let's do part B. Part B करने से पहले let's read the information that we have just before part B. So it says 2 dice are thrown repeatedly until a score of 4 is obtained. So every time a question is of geometric distribution, always watch out for this. Until something is obtained, until a tails is obtained, until a heads is obtained, until a score of XYZ is obtained. Okay, so this is your hint telling you that this is a question that is about geometric distribution. Okay, the number of throws taken is denoted by the random variable x. So x is representing what? X is representing the number of throws it will take to get a score of 4. Okay, now what do we need to find out? We need to find out the mean of x. So first of all, since we're talking about getting a 4, the probability of which we've already calculated is 1/12. Okay, now हाथ क्या आता है, हम एक काम करते हैं, failure की भी probability लिख लेते हैं. So 1 minus 1/12 which is equal to 11/12. Okay, so this is the probability of success, this is the probability of failure. Okay, now what do we need to calculate? We need to calculate the mean of x. How do you calculate the mean of x? We just wrote down the formula 1/p. So that means 1 divided by 1/12 which is equal to 12. Okay, now what does this 12 mean? This 12 means that on average, if you throw the 2 dice 12 times, you can expect to get a score of 4 at least once. Okay, or you can expect to get a score of 4. Okay, that's what mean basically means. Okay, now let's do part C. Part C is the geometric distribution part. It says find the probability that a score of 4 is first obtained on the 6th row. In case you guys can't see, this is basically 6th. Okay, so we need to find out the probability of getting a score of 4 on the 6th row. So what does that tell you about the score on the first 5 throws? What does that tell you? First 5 क्या होंगी? First 5, exactly, first 5 must be failures. Okay, that means the first 5 must be other than 4. Okay, now, so here's what we have to do in part C. We need to calculate that the probability of getting a 4 in the 6th attempt, that's what we need to calculate. And what will this be? This will be not getting a 4 in the first 5 attempts. That means 11/12 into 11/12 into 11/12 for a total of 5 times. And then finally getting a 4 in the 6th attempt. Oh yeah, sorry. 11/15, 11/12. Okay, so the probability that a score of 4 is first obtained on the 6th row means that, see, you can't directly jump to the 6th row. You need to first throw it 5 times before you can throw it the 6th time. Okay, so that means the first 5 times we must have gotten something other than 4. That means it must have been a failure. Okay, so what is the probability of failure? 11/12. So 11/12 raised to the power of 5 into 1/12 raised to the power of 1. And there you go. That's it. That's your answer. Okay, I mean, obviously we'll calculate this. We're not going to leave it over here. So 11/12, let's close the bracket, raise it to the power of 5. Let's see, what do we get? Into 1/12. So we get 0.0539. Okay, correct to 3 significant figures. Although you can write more than 3 significant figures as well, it's no harm. But yeah, this is what you get. Okay, any questions so far? Although we're not done with the question, but still, if you have any questions, feel free to ask. Okay, now comes part D. Part D says find the probability that x is less than 8. Okay, now this is where things get tricky. First, let's understand what is it that the question is trying to ask. So finding the probability that x is less than 8. Now what is x? x is basically the number of throws taken is denoted by the random variable x. So basically the number of throws it takes to get a sum of 4 is denoted by x. And we need to find out the probability that we get a sum of 4 in less than 8 attempts. Okay. So what does this mean? This means that the sum of 4 is obtained in less than 8 trials. Okay. So that means you can get a sum of 4 in the first trial. You can get a sum of 4 in the second trial. You can get the sum of 4 in the third, fourth, fifth, sixth, seventh. Okay. So what does that mean? The probability of getting a sum of 4 in less than 8 trials basically means that you can get a 4 in the first attempt. You can get a 4 in the second attempt. You can get a 4 in the third attempt. You can get a 4 in the fourth attempt, or you can get a 4 in the fifth attempt. Now I know what you're probably thinking. कि इसमें तो दिन लग जाएगा solve करने का, and you're right. We're not going to do it this way, but still we'll first learn how to do it the longer way before we learn the shortcut. Okay. So the probability that a sum of 4 is obtained in less than 8 trials is basically all of this. Okay. It's like, let me put it to you this way. It's like you're playing against, let's say there's a table tennis match, okay? And you're asked to find out the probability that you win against your opponent in less than 8 matches. Okay, that the first win that you get against your opponent is less than 8 matches. So think of the many ways that is possible. It's possible that you win against your opponent in the first match, in the second match, in the third match, fourth, fifth, sixth, all the way to 7th. Okay. Now let's calculate this probability. Okay, like I said, let's first do it the longer way before I give you the shortcut. And once you understand how it's done the longer way, only then will you be able to understand how the shortcut works. Okay. So what is the probability that a sum of 4 is obtained in the first attempt? It's 1 upon 12. Okay. Or if you want to be a bit more formal, you can write 1 upon 12 to the power of 1. What is the probability that a sum of 4 is obtained in the second attempt? That means the first attempt must have been a failure, but in the second attempt, we would have gotten the sum of 4. What is the probability of getting a sum of 4 in the third attempt? That means that the first 2 attempts must have been a total failure, and then finally, in the third attempt, we would have been able to get the sum of 4. And then, what is the probability of getting the sum of 4 in the fourth attempt? 11 upon 12 to the power of 3 into 1 upon 12 to the power of 1. Okay. And then just like that, let's do it for 5 as well. That means the first 4 attempts must have resulted in a failure. And then finally, in the 5th attempt, we would have gotten the sum of 4. And then let's do the same for the first 6 attempts. That means the first 5 attempts would have resulted in a failure. And then the 6th attempt finally would have resulted. Although you can say that we already have this probability, but let's just write it down anyway. Okay. And then what is the probability that that a sum of 4 was obtained in 7 attempts? That means the first 6 attempts must have been a failure, and then finally the 7th attempt we would have gotten what we were looking for. Okay. So one way to do this is right in front of you. Okay. Now I've done this beforehand. Okay, I've done this beforehand so that you guys don't have to, so that we don't have to waste a lot of time trying to figure out what this is. But if you work this out, the answer is going to be 0.456. And you're very welcome to try it. Not right now, later on. You're very welcome to try and figure this out. You'll notice that the answer is 0.456. But this is not at all recommended. Not at all recommended. And for obvious reasons. Okay, it's not recommended for obvious reasons, because then you will only be able to solve one question in the exam. Okay. Now let's try and think of some other way to do it. Okay. So what do you think would be the opposite of x is less than 8? What do you think? X is less than just greater than 8 or something else? Greater than or equal to 8. Okay. So let's put it to words. The probability that a sum of 4 is obtained in less than 8 attempts is basically the same as total minus total, which is 1, minus the probability that a sum of 4 is obtained in 8 or more attempts. Okay. I'll repeat. The probability that a sum of 4 is obtained in less than 8 attempts can be worked out by taking the total and from it subtracting the opposite of x is less than 8, which is x is greater than or equal to 8. Now, if
But won't this be a longer method? Like
what we're about to do,
for this specific question though.
this method,
Yeah, so
no,
because like he's tried like 36 times, right?
no. Okay. See, he hasn't tried 36 times. 36 was basically the total possible outcomes that you can get when you roll 2 dice. That's not the number of trials. In geometric distribution, remember, the number of trials aren't fixed. The event continues for as long as the desired outcome is obtained.
Oh,
Okay, compare this with binomial. देखो binomial में क्या होता था? Binomial में ये होता था कि number of trials fixed होते थे. इसलिए success could all happen multiple times. Like for example, if let's say the number of trials were 10 and you need to calculate the probability of getting 3 tails, then you would take tails, the probability of tails, and raise it to the power of 3, because that means getting tails is possible. Getting tails 3 times is possible. But in geometric distribution, notice that the probability of success is always raised to the power of 1. Why is that? That's because that is the point where this whole thing stops. Okay, that's the key difference between binomial distribution and geometric distribution. Binomial mein you can have success occurring multiple times. Okay, but in geometric distribution, success can only occur once. Okay. Now, let's pick this up again. So the probability of x of basically getting a sum of 4 in less than 8 attempts can be worked out by taking the total probability, which is 1, and from it subtracting the probability that 4 is obtained in 8 or more attempts. Okay. Now, if you're obtaining a sum of 4 in 8 or more attempts, what does that tell you about the first 7 attempts? What does that tell you about? Yes, exactly. That means the first 7 must have been a total failure. Okay. Now, what is the probability of failure? 11 upon 12. And what if you want to fail 7 times? You raise it to the power of 7 and then you subtract it from 1. And there you go.
Right, we want to the power 6, then 1 upon 12 plus 4 1.
Can you repeat that?
Yes. So won't we do it 11 upon 12 raised to the power 6 and then
No. Okay. That does not. Okay. That we would have done if we would have gotten a sum of 4 in the 7th attempt. That means that the first 6 are failures. Here, all 7 are failures. So if you want, you can do this. You can write it like this: 1 upon 12 to the power of 0. But again, it makes no difference at all. Okay, here we're trying to work out the probability that the first 7 attempts are failures. That means the probability of failing raised to the power of 7 into the probability of succeeding raised to the power of 0. Okay, what you're saying is something we would have done if we would have succeeded in the 7th attempt, which means that the first 6 would have resulted in failure. Do you get what I'm saying?
Right. Okay. 1 upon 12 is the probability of
Success.
passing. So
Yeah.
yes, success.
Okay. So if you work this out, you get the same answer, which is 0.456. Okay.
We can then subtract it from 1.
Yeah. So basically 0.456 is the final answer after subtracting it from 1. 11 upon 12 to the power of 7. And then whatever that is equal to, we subtract that from 1, and that's how we get 0.456. Okay. Now I want you guys to remember one thing. We're going to make a standard rule now. Okay. And I'll give you a list of all the standard rules, which you can refer to over and over again. If the question says to calculate the probability of x is less than 8, okay, and in place of 8, you can have any number. Okay. Don't just be totally fixated on 8. Okay, in place of 8, you can have many numbers, any number. That means that we would calculate the probability of x is greater than or equal to 8. And greater than or equal to 8 means what? 7 failures. Okay. Now, if let's say, let me bring this on a separate page. So that's case number 1. Because this is how the question can be twisted. Other than that, there's no way that the question can be twisted. The concept is pretty straightforward. So if, let's say, you need to calculate the probability that x is greater than or equal to 8. So here's how we're going to do it. That means the first 7 must have been failures, okay, just like how we did it earlier. So in that case, what we're going to do is we're going to take the probability of failure and raise it to the power of 7. So you can write it as q to the power of 7, or you can write it as a to the power of 7. 1 minus p to the power of 7. Now, the third possibility is that what if the question asks you that a sum of 4 is obtained after 8 attempts, okay? So if the sum of 4 is obtained after 8 attempts, okay, that means the 9th attempt, let's say, what does that tell you about the first 8 attempts?
8 failures.
8 failures, very good. Which means that you would take the probability of failure, which is q or 1 minus p, and raise it to the power of 8. Okay. And then there is a fourth possibility, which is in between two numbers. So if, let's say, the question says to calculate the probability that a 4 is obtained between, let's say, the 6th and the 9th attempt. Okay. So what does that mean? That means you will calculate the probability of getting a 4 in the 7th attempt, okay, plus the probability of getting a 4 in the 8th attempt. And that's it. Had there been an equals to sign with 6 and 9, then you would have included 6 and 9 as well. Okay. Now, to generalize this, there's something that you can, I wouldn't recommend that you like memorize brainlessly, okay, but you can refer to it again and again when you're solving questions. Okay. And here it is. Okay. The reason why I wrote it down with actual values is because without actual values it can seem a little confusing. Okay. So I'll tell you what we did just now. So what we did just now was this, that the probability of, x is less than 8. So this is what we did. That if, let's say, you're asked to calculate the probability of x being less than r, that means 1 minus the probability of x being greater than 1 minus r minus 1. So technically that's what we did. We had to calculate the probability of getting a 4 in less than 8 attempts. So here's what we did. 1 minus the probability of getting a 4 in 8 or more attempts, which means not getting a 4 in 7 attempts. So 7 is basically 8 minus 1. Okay. So this is something that you can refer to over and over again, although I would prefer that you use this with actual values so you can make more sense of it. And remember, this 8 is not like a golden value or something. Okay, it's just a random value. In place of 8, you can have anything else. Okay. All right, so here's a question from March 2020, paper 5, question 2, part A. So it says, an ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. So again, remember what I said? Look for until XYZ is obtained. Okay. Now it says here, find the probability that it takes at least 3 throws, but no more than 5 throws to obtain a 1 or 6. Okay, so let's first decipher the question. Okay. So what is the probability of success? Let's first try and find that out. Probability of success. What is success? What exactly are we considering success over here? Yeah, sorry, can you repeat that?
Where the success is going to be the favorable outcomes upon the total outcome.
Yep, so we're talking about one die, and yeah, 2 upon 6 or 1 upon 3. Perfect. So 2 upon 6, why? Because 1 is a favorable outcome and so is 6. So 2 favorable outcomes divided by total, so that's equal to 1 upon 3. Okay, brilliant. Now what about the probability of failure? Q or 1 minus p, that is equal to 2 upon 3. Okay, so there you go. This is us basically getting all the information that we need to plug in the formula. Okay. Now we need to calculate that this 1 or 6 is obtained in at least 3 throws, but no more than 5 throws. So that means x is greater than or equal to 3, lesser than or equal to 5. Okay. This is what we need to do. Just a minute. All right. Now, so what does this mean? This means that this can include probability of x being equal to 3 plus the probability of x being equal to 4 plus the probability of x being equal to 5. And because this is not a lot of work, this is how we're going to do it. Okay. So probability of x being equal to 3 basically means that we get a 1 or 6 in the third attempt. Okay. And if we are succeeding in the third attempt, what does that tell you about the first two attempts? That means the first two attempts must have been a failure. And then finally in the third attempt, we would have succeeded. And if you're getting 4 in, if you're getting 1 or 6 in the fourth attempt, that means the first 3 attempts must have been a failure, and then finally the fourth attempt must have been a success. If you're getting a sum, or sorry, not a sum, that was in the previous question. If you're getting a 1 or 6 in the fifth attempt, that means that the first 4 attempts must have been failures, and then in the fifth attempt, we would have finally gotten what we're looking for. Okay. Now let's work this out using a calculator. So 2 upon 3, although this you can do without a calculator as well, but I wouldn't suggest that you risk it unnecessarily. So this is 4 upon 27, okay, plus 2 cube divided by 3 cube into 1 divided by 3. So this is 8 upon 81 plus, let's figure this out. Although the way that I'm doing it is not something I would personally recommend. I would recommend that you plug this in as it is in your calculator till you get the final answer. Okay. All right. So we close this 2 upon. So this is 16 upon 243. Okay. Next thing that we do is we just sum it up. So 4 upon 27 plus 8 upon 81 plus 16 upon 243. So here we have either 76 upon 243, or, although I would suggest that if you're getting an answer in fraction form, you leave it in fraction form only. And there you go. That's your answer. Now, take a good look at what I've done. Let me know if you have any questions. Okay. I'm guessing no questions.
Sir, one question.
Yeah.
Sir, how did you get the probability of 2.6? Like, what was the thing?
Okay. So we're talking about a fair die, which is thrown repeatedly until a 1 or 6 is obtained. So what's our favorable outcome? Our favorable outcome is 1 or 6. Now, how many 1 or 6 do we have printed on any fair die? Okay. Anyway, so let's do this question. So it says here, Ramesh, this is a very recent question, May, June 2022, paper 5, variant 3, question number 4. So it says Ramesh throws an ordinary fair 6-sided die. Okay. Find the probability that he obtains a 4 for the first time on his 8th throw. Okay. So first of all, let's define all the probabilities. Okay. So the probability of getting, what are we interested in? We're interested in getting a 4. So the probability of getting a 4 is 1 upon 6. The probability of not getting a 4 or failure would be 5 upon 6. Okay. So if he's getting a 4 for the first time on his 8th throw. Okay. So again, for the first time.
So he'll fail 7 times.
So he will fail 7 times. Okay. So what's our hint that's telling us that this is a question on geometric distribution for the first time? Okay. So he will fail 7 times, like you said, 5 upon 6 to the power of 7 into q upon 6 to the power of 1. All right. So let's work this out. So 5 upon 6 to the power of 7 into 1 divided by 6. So we have 0.0465. Okay. There you go. That's your answer. Okay.
Sir,
Mhm.
when is the exam in Karachi?
For P1?
Yes.
Okay, I'll share the calendar. Let me just get through this question. Okay, and I'll share the calendar. It's the same date, by the way. Dates aren't different.
Okay. Because here we are having it on 2nd May.
Yeah, so it's the same.
2nd February.
So I think ours on the third.
That-
Yeah, mine is also on 3rd.
That can't be. Yeah, that can't. It has to be the same day. Otherwise, you can so easily cheat. Is that what you were asking? Although I hope not.
I was not asking that. I was just asking that.
No,
Is
I'm
it
just kidding.
different for?
I'm just kidding. Yeah, they have variants for that. Obviously, it's practically impossible to have the exam conducted at the same time everywhere in the world. So that's why they have variants. So you know how this is paper 5 variant 3. So this must have been a variant for some other region. That's why. Okay, anyway, let's just quickly wrap this up. Find the probability that it takes no more than 5 throws for Ramesh to obtain a 4. Okay, what does that mean? That means we need to calculate the probability that x is lesser than or equal to 5. Okay, now did we write that down? Okay, that's the one thing that we didn't write down. Okay, probability of x is lesser than or equal to 5. Now let's understand this. Okay, what does this mean? This means that he can get a 4 in the first attempt, second attempt, third attempt, fourth attempt, fifth attempt. Okay, now tell me something. Can I write probability of x is lesser than or equal to 5 as probability of x is less than 6? Can I do that? See, in the first case, we would include x from 1 to 2, 3, 4, and 5. And in the second case, we would do the same. Considering that x can only take integer values. Obviously, we're talking about number of trials, right? So trials can only be integer values. So in this case, although mathematically, yes, x is lesser than or equal to 5 and x is less than 6 are two different things, okay? Especially when the values are continuous. But let's say x can only take integer values. If x can only take integer values, are these two going to be any different? No. Okay.
Yes, sir. No.
No. Okay. So that means in part B, if I can somehow work this out, that would be the same thing, because if you just do simple translation, it says find the probability that it takes no more than 5 throws. That means 5 is allowed, okay, but it has to be less than or equal to 5, which means that it has to be less than 6. Now the good thing about writing it like this is we know how to work this out. We know that in order to work this out, we can simply write it like this: 1 minus the probability of x is greater than or equal to 6, and the fact that it's greater than or equal to 6 means what? Means that we would have first 5 as failures. Okay, so here's what we have done. Probability that x is less than 8 is equal to 1 minus the probability that x is greater than or equal to 8, which means 7 failures. So here, probability of x is less than 6 means 1 minus the probability of x being greater than or equal to 6, which means that we would have the first 5 failures. And what is the probability of failing? 5 upon 6 and raise it to the power of 5, because we are talking about first 5 failures. Okay, now let's work this out. 1 minus fraction 5 upon 6 to the power of 5. So let's work this out. Here's what we get: 4651 over 77776, or you can write it as decimal 0.598. And there you go. That's your answer to part B. Does everyone understand this?
Yes, sir.
Okay, great. All right, let's do part C. Now, part C is the same question, but let's see how it's different. So it says for 10 randomly chosen throws of the 2 dice, find the probability that Ramesh obtains a total of less than 4 on at least 3 throws. Okay, so here we're talking about 10 randomly chosen throws. So where does that happen, that the number of trials are fixed? In what distribution is the number of trials fixed and the probability of success and failure also fixed? It doesn't happen in geometric distribution. Binomial distribution. Okay, so now this part of the question involves binomial distribution. Okay, so let's do this since we've already done binomial distribution. So let's see what is considered success. So success is basically a total of less than 4 on at least 3 throws. Okay, so here we're talking about 2 dice that we are throwing. Okay, and we are interested in finding out the score being less than 4. So let's write down all the scores that are less than 4 first. Okay, since we're talking about 2 dice and total, so that means we're summing up the 2 scores. So 1, 2, 3. Again, no need to fill up all the values. Okay, since we're only interested in less than 4. So this would give me less than 4, this would give us less than 4, this would give us less than 4, and that's it. Everything else would give you more than 4. 4, 4, 5, 5. So what is the probability of success, which is getting a score less than 4? 3 upon 36, which is equal to what? Which is equal to 1 upon 12. Now what would...
Sir, but 3 times. Sir, could you go up?
Yeah. Sure.
How are we gonna find out, like, obtains the total of less than 4 and at least 3 throws?
I'm sorry, can you repeat that?
Sir, I don't get how you're gonna, like, calculate the 3 throws. Like, I understand too, but
Okay. So remember, this is binomial distribution. Okay. So we need to calculate the probability that Ramesh obtains a total of less than 4 on at least 3 throws. So that means that could be 3, 4, 5, 6, 7, 8, 9, 10. Okay. Which obviously is not feasible. So what's feasible? What's feasible is that he gets a total of less than 4 in lesser than 3 throws, and then we can subtract it from the total. You get what I'm saying? So instead of doing x is greater than or equal to 3, we can do 1 minus the probability of x is less than 3. Okay. So what's the probability of q? The probability of q is 11 upon 12. Okay. Now, so x belongs to binomial distribution where the number of trials are 10 and the probability of success is 1 upon 12. Okay. And let's write it down. X is the number of times a score of a sum of, or you can say a total of, less than 4 is obtained. Okay. And what do we have to calculate? We have to calculate the probability that, let's read the question, that he obtains a total of less than 4 on at least 3 throws. That means we need to calculate that he obtains a total of 4 on 3 or more throws from a total of 10. Okay. So that obviously is not a good idea, because that means that we calculate the probability of x equal to 3, x equal to 4, and then take this all the way to 10, which, like I said, is not a good idea. But what's a better idea is this, that we do 1 minus the probability of x is less than 3. Okay, and what are we going to include in less than 3? We're going to include the probability that he obtains, the probability that x is equal to 0, plus the probability that x equals to 1, plus the probability that x equals to 2. Okay, what does that mean? That means that he obtains a total of less than 4 0 times, once, and twice. And if we subtract the total of that from the total probability, which is 1, we will have the probability that he obtains a total of 4 at least 3 times. Okay, do you guys get it? Yes or no?
Yes, sir.
So 10C0, 1 upon 12 to the power of 0, 11 upon 12 to the power of 10, plus 10C1, 1 upon 12 to the power of 1, 11 upon 12 to the power of 9, and then finally 10C2, 1 upon 12 to the power of 2, and I've run out of space, so let's drag this here, 11 upon 12 to the power of 8. Okay. Now if you work this out, so just to save some time, I'll just write down the final answer. It is going to be 0.445. Okay. Now I'll explain this again. So first of all, you need to realize that this question from geometric distribution has shifted to binomial distribution. Why? Because the number of trials are now fixed. If the number of trials are now fixed, that means it can only be binomial distribution. Okay. Now what is it that we're interested in? What will be considered success? Success would be considered that a total of a sum of less than 4 is obtained. Okay. And what exactly are we doing here? We're rolling 2 dice and we're adding them up. So the probability of success becomes 1 upon 12. The probability of failure becomes 11 upon 12. Okay. Now the question says that find the probability that Ramesh obtains a total of less than 4 on at least 3 throws. Okay, from a total of 10. So that could mean 3, 4, 5, 6, 7, 8, 9, 10, which is obviously not feasible. So instead, what we did was we took 1, which is the total probability. From it, subtracted the probability that a sum of less than 4 is obtained lesser than 3 times. So that means 0, 1, 2. And if we subtract that from the total, we would have the opposite, that which is a sum of less than 4 is obtained at least 3 times. Okay, now any
Okay, sir.
any questions?
No, sir, I understand.
All right. Okay, now so I'm gonna stop here. I'll upload this in our shared folder. You guys can download it from there. I'll also attach some practice questions which I'd like you guys to solve. And yeah, or you can do the questions from the topical past paper book that I shared. Okay, it's up to you. So take care, everyone.
Sir, I have a question.
Mm-hmm. बोले बोले.
Sir, topical past papers अभी शुरू कर देने चाहिए for S1?
Yeah. Topical nahi. In fact, you should start yearly now, considering that we're only left with 2 topics: normal distribution and permutation and combination. So you can start yearly
Okay,
past
so
papers.
Okay, yearly past papers.
Abir, you were also saying something?
So I'm saying the question that you uploaded, the very hard questions. If we just cover those, do you think like that'll be enough practice?
Yeah, that will be. But like it's a good idea to solve past paper questions as well. So you're familiar with. Although if you do the very hard questions, they're more difficult than past paper questions. So if anything, they'll make past paper questions look easy. But still, do practice past paper questions so that you get familiar with the terms and the structure that you will find in past papers. Okay. So okay, take care. Love is.